Determine the orthocenter of a triangle formed by the lines x plus y equals to 1, 2x plus 3y equals to 6, and 4x minus y plus 4 equals to 0. Okay, let us begin. So what we have here is a triangle, and the sides of the triangle are given in the form of an equation. So let's say we have the triangle ABC. We're supposing that the side AB, let's say it's represented by the equation x plus y equals to 1. We're going to label this as number 1. Then we have the side BC. We're going to denote BC by the equation 2x plus 3y equals to 6. Let's call it equation number 2. And then we have the third side CA. CA is going to be represented by the line 4x minus y plus 4 equals to 0. We're going to label this as number 3. Now, that is what is given to us. Using this, we need to find out the orthocenter. That means the coordinates of the orthocenter of the triangle. The orthocenter is simply defined as, so from point A, we're going to draw the perpendicular on the line BC. Now let us suppose that AD is perpendicular on BC. Similarly, from B, we're going to draw another perpendicular on AC, and from C, we're going to drop a perpendicular on AB. So here, as we can see, all of the three altitudes, AD, BE, and CF, are going to meet at a common point O. The O is going to be referred to as the orthocenter of the triangle. So our goal will be to determine the coordinates of this orthocenter. So to begin with, what we'll do, first we will try to find out the coordinates of the vertices A, B, and C. Now that's a very easy task. To find out the coordinates of point A, all you have to do is take the two sides, the adjacent sides, AB and AC, because AB and AC are given by the equation of lines. When you solve these two equations, we're going to get the value of x and y, and that is going to give us the coordinates of point A. So let us begin. We'll first find out the coordinates of point A by solving the side AB and AC. X comes out to be negative 3 over 5, and y comes out to be positive 8 over 5, which means that the coordinates of point A, that is going to be negative 3 over 5, and then we have y, so that's going to be positive 8 over 5. Now let's now find out the coordinates of point B. So to find out the coordinates of point B, we need to solve the sides BA and BC. So BA and BC means we have to solve equation 1 and 2. Now x is going to be equals to negative 3, and corresponding y value, that comes out to be positive 4, which means that the coordinate of point B, that is going to be negative 3 comma positive 4. So similarly, we can obtain the coordinates of point C. So that comes out as negative 3 over 7 comma 16 over 7. Okay, so now we have the coordinates of the vertices A, B, and C. So in order to find out the coordinates of the orthocenter, what we'll do, we are going to find out the equation of any two altitudes. We can find out altitude AD and BE, and we can solve that to find out the point of intersection. So we need only two equations at a time. So let's do one thing. Let's try to find out the equation of the altitude AD. Then we will find out the equation of altitude BE. Now, we have to take a route here to find out the equation of the altitude AD, because here we only have the equation of the side BC. Now we know that BC is going to be perpendicular to AD, and whenever we have two lines that are perpendicular to each other, then their product of the slope equals negative 1. We're going to use that fact to find out the slope of the line AD, and once we know its slope, we can use the point slope form, because the line is also passing through the point A, to find out the equation of AD. Okay, so let's use the line BC. So for the line BC, so we have 2x plus 3y equals to 6. We're going to rearrange it. So we have 3y, that is going to be equals to negative 2x plus 6, which is going to be y equals to, dividing each terms by 3, we're going to get negative 2 over 3 times x, added to 6 divided by 3, that's going to be 2, which means that the slope of the side BC, this implies that slope of the side BC, that's equals to negative 2 over 3. Now here we have the AD perpendicular to the line or to the side BC, and this would simply imply that if we take the slope of the line AD and multiply it to that of the slope of the line BC, they must give us negative 1. That is the rule. which means that slope of AD, that is going to be equals to -1 over the slope of the line BC. Since we have already obtained the slope of the line BC, -2 over 3, so if we take the negative reciprocal of the number, that comes out to be 3 over 2. So now we have the slope of the line AD, so the slope is 3 over 2. Now we have a straight line having a slope of 3 over 2, passes through the point A with the coordinates -3 over 5, 8, 5. So we can find out the equation of the altitude AD. The equation of AD, that is going to be equals to, so we did y minus y1. So y1 is going to be the y coordinate of point A. So that's 8 over 5. Equals to, we need the slope of AD. We have already obtained, that's 3 over 2. Multiplied to x minus x1. So x1 is going to be the x coordinate of point A. So that's -3 over 5. So we're going to get positive 3 over 5. Okay. So let's simplify this. We're going to multiply throughout with 5. So that's going to give us 5 times y minus 8 equals to 3 over 2 multiplied to 5 times x plus 3. Then we're going to multiply throughout with 2 to get 10y minus 16 equals to 3 times 5x plus 3. Further simplification gives us 10y minus 16 equals to 15x plus 9. We get 15x minus 10y plus 25 equals to 0. Each of the terms have got factors of 5. So our equation becomes 3x minus 2y plus 5 equals to 0. So this is going to be the equation of the altitude AD. Next, let's try to find out the equation of the altitude BE. First, we are going to consider the side opposite to that of angle B, which is AC. We're going to find out the slope of AC. To find out the slope of AC or CA, it's the same thing. We're going to rewrite this equation. So we had 4x minus y plus 4 equals to 0. So here y is going to be equals to 4x plus 4, which means that slope of the line AC, that is going to be equals to positive 4. Now we can say that since the line BE is perpendicular to the line AC, that would imply that slope of the line BE, that is going to be equals to the negative reciprocal of the slope of AC. So we should get -1 over 4 as the slope of the line segment BE. So now we have the line passing through the point B, -3, 4, and it has a slope of -1 over 4. So equation of BE, so that is going to be, we need y minus y1. y1 is going to be the y coordinate of point B, that's 4, equals to the slope -1 over 4 multiplied to x minus the x1. x1 is going to be the x coordinate of point B. Since it is -3, we're going to get x plus 3. So let's simplify this, and we're going to get the equation. We get x plus 4y minus 13 equals to 0. So this is going to be the equation of BE. So now we have successfully obtained the equation of AD. We have the equation of B. Let's solve this two equation, and that is going to give us the coordinates of the orthocenter O. So we have the equation of AD. So here let's use the rule of series. We're going to take the coefficient of y for equation AD, that's -2, followed by the constant term, that's 5. Come back to the first term, consider the coefficient of x, that's 3, and end up with the coefficient of y, which is -2. Then we do the same pattern for the second line BE. So we'll start with the coefficient of y, that's 4, followed by the constant term, that's -13. Come back to the first term, which is the coefficient of x, that's 1, and then end up with the coefficient of y. So we now have x, y, and 1. We're going to perform cross multiplication. So that's going to help us obtain the value of x and y. So what we get here is x divided by -2 multiplied to -13, that's going to give us positive 26, minus 4 times 5, that's 20. That's going to be equals to y divided by, so 5 times 1, that's 5, negative 3 times -13, that's -39, but we already have a negative sign, so we're going to get positive 39. This is going to be equals to 1 divided by 3 times 4, that's 12, minus 1 times 2, that's 1 times -2 gives us -2, but we have a negative sign, so we're going to get positive 2. So we have x over 26 minus 20, that's going to be 6, equals to y over 39 plus 5, so that's going to be 44, equals to 1 over 12 plus 2, that's going to be 14. So we have x equals to 6 over 14 and y that is going to be equals to 44 over 14. So 6 over 14 we can reduce it to get x equals to 3 over 7 and y that's going to be equals to 22 over 7. So we have successfully obtained the coordinates of the orthocenter. We can say thus the coordinates of the orthocenter are 3 over 7, that's the x coordinate, and the y coordinate is going to be 22 over 7.